Okay, we're going to start our second part of our trigonometry unit where we're going to be looking at angles and how that relates to location around a quadrant system. So today we're going to focus on calculating reference angles and what these mean to us. So you can see in this case, if I was to draw 150 degrees, that angle would be about there. And you can see here I've got the reference angle listed at 30. So we're going to figure out how to calculate those and where we can locate things. So in math, we always use 0 degrees as going straight to the right on our x-axis. 90 would be up, 180 is to the left, and 270 is straight down on the y-axis. So if we were trying to locate an angle, something like 200 or let's say about 310 degrees, something like that. So if we're doing 310, we'd go to 90, to 180, to 270, and then we'd go 40 degrees past that to get to 310 degrees. So if that angle that I've got labeled on this picture is 310, then that would be our position for that. But we could also, if we wanted to, we could also do it in the negative direction. So we could say instead of going around 310, we could go backwards 50 degrees. So negative 50 degrees would also give us the same location. Most often we do positive, but the negatives do occur. So let's look at a few different ones, and we'll just use this same grid. So where would 120 be located? So if we were to try to draw 120, we would go past the 90, and we'd go another 30 degrees or so, and that would give us 120. So there's 120. 309, we know 360 is all the way around, so 309 would be not quite all the way, so it would be something like that. And 17 degrees would be pretty small, so it would be somewhere over there. And let's clear those off and we'll do the rest. So now we're at 510. So 510, you gotta be a little bit careful. We got 360 to go all the way around. So that just means we're still going. So we're gonna repeat again. So 360 plus 90 is 440. So then to get to 510, we'd have another 50 degrees or so. So it would be somewhere over there. So anything bigger than 360, it just means we're going around multiple times. And we can do this as many times as we want. So we could go around another 360 if we want, get to the same location, and we'd be at 870. We just add 360 on. Okay, so let's clear those. So the next one, negative 108. So that just means we're going backwards. So 90 would be to there, 108 would be a little bit past. And negative 210, same thing. That's negative 180. So negative 210 would be somewhere about there. And the last one, 405. So we know it's 360 all the way to here. So that means we have another 45 degrees or so past the 360 mark. And that's it. So it's pretty easy just to locate your angles. Just remember the 90, 180, 270. So now coterminal, we've already kind of done a few. So coterminal is when those angles are exactly the same. So let's kind of resketch this one. So if I draw 120, so that's 90 plus 30 would give us 120. So that's correct. Or we already saw that we could go backwards. So if I go backwards, that would be negative 240. So that would also be the same angle. Or I could go around 120 plus another 360 would also give us 480. So all three of those angles are in the exact same location, so we call them coterminal. Typically, we're going to use the smallest positive to be the one that we want to refer to. So typically the 120 would be our normal standard angle that we would call. Okay, so let's do a few trig type questions now. So now they're going to, instead of giving us the angle, they're going to give us a coordinate. So if we were to draw the point 24, so our coordinate would be somewhere down there, 2, negative 4. So that means our angle would be like that. So the question's saying, what is the actual location of that angle? So we're going to be looking for what's the angle all the way around like that. So we got a couple options. We can either figure out this angle, and that's probably the easiest. So if we draw a triangle out of this, we went over 2 and down 4. So the easiest way is just go tan opposite over adjacent. So tan theta is 4 over 2. We do that on our calculator. and we get 63 degrees. So if that angle is 63, we can see that our total angle all the way around would be 360 minus 63, so that would give us 297 degrees would be our correct answer. Okay, the other option is we could have found the other angle, and then we just add 270 to it, but this is probably the better way to go. So let's try a couple more. So this next one.
Mrs. Hamilton, contact the office, please. Mrs. Hamilton, contact the office.
So if we draw a triangle, it would be 1 over and 3 up. So let's again find that angle. So in this case, we'd go tan would be 3 over 1. So if we go second tan of 3 over 1, we get 72 degrees approximately. So in that case, you can see that that would be 72. So our angle to go all the way around would be 180 minus 72 would give us 108. And the last one, same thing again. We're going backwards 5 and down 1. So we'd have 5 down, or 5 left and 1 down. So once again, our angle would be second tan of 1/5. So on your calculator, that gives you about 11 degrees. So in this case, we want 180 plus the 11. So our total answer then should be 191. Okay, so we're just basically doing trig to figure out what the angle is and then adding it to whichever quadrant to be able to get our exact standard location. Quite often those standard angles are going to be a little bit more difficult to work with, so usually what we're going to do is work with reference angles. And reference angles are actually what your calculator gives you. When you do tan, cos, or sine, you're actually normally dealing with your reference angle, not the standard angle. So the reference angle is defined as the angle between the x-axis and the terminal arm. So if we draw 150 degrees, it looks like that. So our reference angle would be the other angle, which is going to be 30 in this case. So no matter how you draw your angle, usually we want to figure out the reference angle. So 243 would be 180. So it'd be something like that, is 243. So our reference angle in this case then is going to be that angle between the x-axis and the 243. So we know that's 243, we know that one's 180. So 243 minus 180 gives us an answer of 63. So that's our reference angle for that question. So if we do the same thing for 337, 337 would be somewhere in there. So we can see in this case full circle would be 360. So if we go 360 minus 337, that gives us an answer of 23 degrees. So that would be our reference angle in this case. And our last one, 70 degrees. Our reference angle is always between the x-axis, so 70 is the reference angle, so we don't need to do any calculation. So quite often in your quadrant 1, your angles will be already the reference angle. Okay, so let's do a few examples, and that'll be it for today. So we want to draw the reference angle in each quadrant. So reference angle of 58, so that would be something like that. So if we put that in every quadrant, remember it's always between the x-axis and the line. So we'd have 58 in all 4 quadrants like that. So that's our reference angle. So now let's calculate the actual standard angles. So this one, 58, stays the same. The next one would be 180 minus 58, which would give us 122. You can see down here we have 180 plus 58, which would give us 238. And the last one would be 360 minus 58, which would give us 302. So there's our 4 angles. So all 4 of those different angles have all of the exact same reference angle. So we can also do this with coordinates instead of angles. So 5, 8 would be something like that. So we're going 5 over and 8 up. So whatever that angle is as a reference angle, it's going to be the same in all quadrants. So the easiest way to do this is just actually change our coordinates. So if we went 5 over and 8 up, that'd be the same thing as going 5 backwards and 8 up, or 5 backwards and 8 down, or 5 forwards and 8 down. So all 4 of those coordinates would be the exact same reference angle too, because if we were to do our tangent, they'd all be 8 over 5, no matter how we do it. The negative is just going to indicate which quadrant it's in. And the last one, so this one says we have an angle at 256. Let's figure where that is. So 256 would be something like that. So our reference angle on 256 would be 256 minus 180 would give us 76 degrees. So that means we have 76 in that quadrant to give us the 256. So the question's saying, what are the other 3 quadrant angles going to be? So if we put our 76 in all 4 quadrants, and then we just need to figure them out. So 76 in the first quadrant would stay the same, 76. The other one would be 180 minus 76, which would be 104. And the last one would be 360 minus 76, which would give us 244. So there's our 4 angles again that have the exact same reference angle. And that's all for today.